Examples of travelling transverse wave. Now look at number 1. Part A. There are two complete waves, and the wavelength lambda is equal to 6/2 equal to 3 cm, and the amplitude of the wave A is equal to 2 cm divided by 2, which is 1 cm. For B1, the particle that is instantaneous at rest or stationary is this one, P. B2, the particle that is moving upward is this one, Q. 3, the particle that is moving downward is this one, R. For B4, for the particle moving to the right, O. The low particles is moving to the right. Only the wave is moving to the right, and the particles along the wave are vibrating vertically. They are vibrating in a direction perpendicular to the direction of wave motion. Therefore, low particle is moving to the right. For part C, the particles that are moving in phase 同步 are particle Q and particle X. Q and X. While the particles that are moving anti-phase are Q and R. These two particles, Q and R. For part D, after a time of a quarter period, T/4, the new wave train will be Notice that after a time of a quarter of period, the wave move forward a distance equal to a quarter of wavelength. Now look at question number 2. The wavelength of the wave lambda equal to 15/1.5 because along AB there are altogether 1.5 complete waves. Therefore, lambda equal to 10 cm, and the frequency of the wave F equal to V over lambda equal to 20/10, which is 2 Hz. For part B, the instantaneous motion of particle A is moving downward, while the instantaneous motion of particle B is moving upward. The period of the wave is T equal to 1/F equal to 1/2 equal to 0.5 seconds. For part C, after a time 0.25 seconds means 0.25 seconds is equal to 0.25 over 0.5 period equal to half period's time. After 0.25 seconds or half period's time, the new wave train along AB will become the red one. Since the wave is traveling to the right and the particles on the wave is moving up and down, therefore the wave produced on the string is traveling transverse wave. The figure shows 2.5 complete wave. The wavelength equal to 7.5 over 2.5 equal to 3 cm, and the period equal to 0.1 over 2.5 equal to 0.04 second. Therefore, frequency equal to 1 over t equal to 1 over 0.04 equal to 25 Hz. And the wave speed v equal to f lambda equal to 25 times 3, which is 75 cm per second. For part C, since wave speed is independent of frequency, therefore, if the frequency of the wave is doubled, the wave speed is unchanged. By lambda equal to v over f, if f is double but v remain unchanged, therefore the wavelength will be halved. Now look at question number 4 and 5. For question number 4, we use the equation v over f lambda. For the first row, the wavelength lambda equal to v over f equal to 0.4 over 20 equal to 0.02 meter. For the second row, frequency equal to v over lambda equal to 0.2 over 0.5, which is 0.4 Hz. For row 3, wave speed v equal to f lambda equal to 2.5 times 0.12, which is equal to 0.3 meter per second. For question number 5, the frequency equal to 10 Hz, which means the period of the wave equal to 1 over f equal to 1 over 10 equal to 0.1 second. For particle x, the time for one oscillation is equal to 1 period's time, and the total distance traveled during one oscillation is a altogether. The distance traveled is 4a. Therefore, the average speed of particle x is equal to total distance traveled in a period time 4a over time is t equal to 4 times 4 over 0.1, which is equal to 160 cm per second. Similarly, for particle y, when it makes one oscillation, it travels a distance of A, altogether there are 4A. The average speed of y is again equal to distance over time. During a time of one period, t, it moves a distance of 4a. Therefore, the average speed of y is again equal to 4a over t, which is equal to that of x. Therefore, the average speed of y is 160 cm per second. In fact, all the particles along the string will vibrate up and down. They have the same average speed. Now look at question number 6. For part A, the particles at rest is P. The particle moving upward is Q, and the particle moving downward is R. For part B, after 3/4 of a period's time, the wave along RQ will become the green one. Also, the wave will move forward, that is, move to the left, by a distance of 3/4 of complete wave. That is, the wave will travel a length of 3/4 of wavelength longer.